We're finishing up first semester material today with our very last lesson, which is extremely exciting, and we're talking about inequalities in triangles. Now, the bulk of this stuff is just listing the angles or the sides of a triangle in order from smallest to biggest or biggest to smallest. So it's not super complicated, which is kind of nice. There's two theorems that we're going to be looking at on the front, two things we can prove. The first deals with the angles in a triangle, and the second deals with the sides. And they're very similar. So if we look at this first theorem, it says that the largest angle of a triangle is opposite the largest side. Okay, and make a note on here that opposite just means across from. Okay, so the largest angle is across from the largest side. Now, it works the same way if you insert the words like smallest instead of largest. So I'm going to put that kind of in parentheses there. Or you could say like, and vice versa. The smallest angle of a triangle is opposite the smallest side. So basically, here's how you're going to figure this problem out. It says list the angles, KLM, in order from smallest to biggest. Please read carefully. The mistake is made every single year. People just do biggest to smallest. Please read, because they will flip that around. Now, if you want to find the smallest angle, you need to look for the smallest side. So the smallest side of this triangle is KL, right here. Opposite or across from that side, so if I draw an arrow away from it, that's the angle that it goes with, which is angle M. If that's the smallest side, angle M has to be the smallest angle. Now if I look at the second longest side, or the second shortest side, that's that guy right there. Across from him, that's angle L, so that's got to be the middle angle, since 4.3 is the middle side. And then the biggest side is 5.8, so across from that is angle K, which would be the biggest angle. Okay, so you don't need any of the angles to be able to list them from smallest to biggest, as long as you have the sides. And it kind of makes sense, if you think of my hands as like an angle, across from them, so if I put my fingers together, that would be the side that it goes with. So like, the bigger the angle between my hands, the bigger that side has to be. And the smaller they are, the smaller that side has to be. So it just, I mean, it makes sense. It's like common sense. Now, make a little note here. Notice that you can only list these angles. You cannot find the actual measure of each angle. So there's no possible way for me to say, oh, angle K would be 102 degrees. I have no way to say the measure. I can only list them. All right, example 2 here is pretty much the same thing, except they don't give me the picture. So if they don't give you the picture, you absolutely need to draw one. I'm going to highlight that because I wouldn't try to do it without a picture. I'd make my own. So they're talking about triangle PHT. Makes no difference how you label them. They tell me that side PH is 16 centimeters. TP is 20. And TH is 13. So I want to kind of do the same thing, except notice they flipped it on me. I want to go from the angles from biggest to smallest. All right, if I want to say the biggest angle, I'm going to locate the biggest side, which is 20. Across from that, H would be the biggest angle. 16 is the second biggest side, so that would go with angle T. And that would have to be angle P, left to be the smallest. Okay, so you'll see a lot of problems like that. Also, it works in the other way around. So this time they're going to give you the angles, and they want you to compare the sides. So the largest side of a triangle is opposite the largest angle. So you guys, it's the exact same thing we wrote for theorem 1, but flip-flopped. It's in reverse. I'm going to make a note here too that this works for the smallest too. So like the smallest side of a triangle is opposite the smallest angle. Okay, so we've got 2 examples here as well. Example 1 says, list the sides in order from smallest to largest. Okay, if they don't give me all 3 angles, I want to find the third so I can compare this accurately. Got a glare. All right, so I'm going to do 180 minus 75 minus 45. Angle M is 60 degrees. All right, so I want to find the smallest angle, which would be angle O right here. Across from that, MN would have to be the smallest side. The middle angle is 60. Across from that is side ON. And then the largest angle is 75. Across from that, MO has to be the biggest side. You can flip-flop your letters. That does not matter. For example 2, same thing. If they don't give you a picture, definitely draw one. This is triangle DBQ. All right, so they tell me angle D is 51. Angle V, ooh, this is weird, is 4x plus 3. And angle Q is 5x minus 18. I need all 3 angles to be able to work this out. So I'm going to add the 3 angles together. So I can find x, and I can see what all the angles equal. So set it equal to 180. And I'm going to combine all my like terms here. We got a lot going on. Okay, so that's 9x. And then if I put all of those plain numbers together, I get 36 equals 180. We should all be able to solve it from there, so I'm just going to finish on my own. You get x is 16. Okay, I need to plug in x to find those missing angles. So 4 times 16 plus 3, angle V is 67. 5 times 16 minus 18, angle Q is 62. Whew, okay, now I can answer the question. They want me to list the sides from longest to shortest. Okay, so the longest, or the biggest angle, I should say, is angle V. Across from that is side DQ. Okay, so that would be the longest side. The middle angle is 62. Across from that, DV is the middle side. And the smallest angle is 51. Across from that, BQ would be the smallest side. All right, we got one more theorem on the back, and this is the title of the lesson, so this is kind of like the big thing. It's called the triangle inequality theorem. And if you looked it up online or like looked it up in a book, this is kind of what it would say, which we know it gets all mathy, and it like loves using variables and all these symbols. They call the sides of a triangle A, B, and C. So if we try to decipher kind of what the theorem says, it says if you add A plus B together, that should be bigger than C. If you add A plus C together, that should be bigger than B. If you add B plus C together, that should be bigger than A. So I don't know about you, but I don't like that. I kind of want to like rephrase that into something that makes a little bit more sense. What they're trying to show you guys is that if you add any 2 sides of a triangle together, that sum, that number, should always be bigger than the third side. Okay, so let's kind of note that in there. If you add 2 sides of a triangle, it must be bigger than the third side. If it's not, that number, if it's not bigger than the third side, then you just can't make a triangle out of those three numbers. So that's exactly what they're asking in the first example. Can a triangle have the given side lengths? So you could test all three possibilities. 4 plus 6, that needs to be bigger than 9. And, okay, yeah, that'd be 10 is bigger than 9, which is true. I should add 6 plus 9 together, and that should be bigger than 4. And that would be, yeah, 15 is bigger than 4, so that checked out. And the other combination, I should be able to add 4 plus 9 together, and that should be bigger than 6. And yeah, 13 is bigger than 6. So if those all check out, then you say yes. Now, let me show you a shortcut to that. You don't have to test all three combinations. If you just test adding the smallest sides together, 3 plus 7, if that sum is bigger than that third side, 12, that's the only combination you have to check. And I can see right now that 10 is not bigger than 12. So this is a big fat no. Okay, if I look at this part C here, same thing. You only have to test the two smallers together, seeing if that's bigger than the biggest side. This one right here will tell you yes or no. And I see 10 is bigger than 10. No, that's not true. 10 is equal to 10, but it's not bigger. So right there, I know it's a no. All right, the last type of example that you'll see for this whole semester, example 2 says, the lengths of two sides of a triangle are given. Find all the possible lengths of the third side. Okay, so I know one side's 7, I know one side's 9. I want to know what's the range for the third side of the triangle. So kind of what I say is, like, if you don't know something, you call it x. So let's say the three sides of a triangle are 7, 9, and x. I know that if I add two sides together, it has to be bigger than the third. So here's what I'm going to do. I know that if I do 7 plus 9, that should be bigger than x, the third side. If I add 7 and x, that should be bigger than 9. And I know if I add 9 plus x, that should be bigger than 7. So I kind of just did all three combinations. Add two sides together, bigger than the third. I'm going to work all these out. So this one would be, let's see, 16. If I subtracted 7 on the middle one, it'd be x is greater than 2. And if I subtracted 9, this would be x is greater than negative 2. Okay, I'm going to flip this guy around so we can kind of like read it a little bit better. Mouth open towards 16, so when I flip it, the mouth should still open towards 16. These ranges are going to kind of tell me where that third side can be. And this one makes no sense. You can't have a negative side length, so get rid of it. I only care about these two. These tell me where my third side length has to be. It has to be a number that's smaller than 16, and it has to be a number that's bigger than 2 to complete the triangle. So here's how I'm going to write that. I'm going to write it as a compound inequality, which is like x is between 2 and 16. I want x to be bigger than 2 and smaller than 16. Realize that these are always going to be less than signs, and they should definitely point the same way. I mean, they're both less than, so point them the same. That's the range. Any number between 2 and 16 would complete the triangle. Let me show you a major shortcut to this problem. You just need the two numbers, okay? You don't have to write any of this that I just wrote. Here's what you can do. To get the low end number, you just subtract the two side lengths. So that's 9. To get the high end number, you just add the two side lengths. 37. Done. I could have done that here too. 9 minus 7 is 2. 9 plus 7, 16. So save yourself all this work, use a shortcut.